In this video, we'll be talking about how to simplify rational expressions. To start with, some definitions. We call the quotient of two algebraic expressions a fractional expression. And we call the quotient of two polynomials a rational expression. You may ask yourself, what's really the difference? Well, a fractional expression would be something of the form square root x plus 5 over x minus 3. Because of the square root, it's not a polynomial. Whereas a rational expression would be something like 3x cubed minus 5x over x squared plus 1, for instance, because both the top and the bottom are polynomials. So now for the big idea when it comes to simplifying, we know that we can reduce fractions by factoring out common terms and then canceling. This is very straightforward. For numbers, namely, we go ahead and we factor the top and bottom. We get 2 times 3. In the bottom, we have 2 times 2 times 2. So there's a 2 in the top, there's a 2 in the bottom with multiplication in between, so we can factor those. We can cancel those, sorry. What we have left is a 3 in the top and a 2 times 2 in the bottom, which is 4. So essentially all we're doing here is we're reducing the fraction by canceling terms out, okay? Common terms in the top and bottom. Here we can do the same thing. Namely, we recognize B and C are in the top and in the bottom, so we end up with A over D. Here we have to be a little bit careful with the addition. Namely, we need factors. What can we factor the top as? Well, we can factor out the common factor of x, have x plus 2 left over, and then the bottom we can factor out an x and have an x squared left over. And because we have an x here and an x here as factors, we can cancel them, and so we end up reducing this, or simplifying down as it were, to x plus 2 over x squared. So now let's try it with something a bit more complicated. Let's try to write this in its simplest form. So solution. We can factor the top and the bottom. The top, we can factor out a common factor and get x plus 3. On the bottom, it's a little bit hard because it's a trinomial, but what we're looking for is two numbers which multiply to give us -3, add to give us -3, multiply to give us -18. What would work here? It looks to me like, so 18 has factors what? 1, 18. 2 and 9, 3 and 6, and I think that's it. Well, it looks to me like if I had positive 3 minus 6, that would work. So x plus 3, x minus 6. Going through and factoring, we notice that we have an x plus 3 in the top and in the bottom, so we can cancel those. In other words, we have left 4 over x minus 6. Now, before proceeding, it's important to note that division cancels factors, not terms. That is, subtraction is how we actually cancel terms. Namely, what's wrong is to say, oh, well, because there's a 6 and a 3 there, I can cancel them. Well, no, because this is an addition, not a multiplication. And so you may say, oh, well, I could cancel that and make that a 2, make that a 1, so I get x plus 2. That is very bad to do. On the other hand, though, if I do x plus 6 minus 3, I say, oh, well, the addition and subtraction cancel in some way. And of course it does. It's like terms. X plus 3. So that's good. Okay? So please be aware of it. It may seem silly right now, but this mistake happens all the time when people are starting off doing this. So, for example, let's go ahead and try writing this in simplest form. So, solution. Factoring the top, again, we need two numbers which are factors of 12 that add to 1 here. So what would work? Oh, actually first, let's go ahead and factor out a negative. That'll make it easier to see. Negative times x squared plus, minus x minus 12 over the bottom, which is 2x squared minus 9x plus 4. For the top, we need two numbers which multiply to give us negative 12, but add to give us negative x. 5 and negative 6 seem ideal. So x plus 5, x minus 6. You can always check this by foiling it out to make sure you get back to that. For the bottom, we need the AC method. So let's go ahead and do 2 times 4, which gives us 8. And so now we need two factors of 8, which gives us to negative 9, negative 8, and negative 1 give us negative 9. So now we use grouping. So we have 2x squared. We break it up into minus 8x and minus 1x. So let's go ahead and just group it, and then we have plus 4. Here we can pull out a 2x. Here we can pull out a negative 1. We have x plus 4 and x minus 4 and x minus 4. And so we have 2x minus 1 times x minus 4. Putting those into here, we have 2x minus 1 and x minus 4. And of course, me being me, I broke this up wrong. This actually factors into x plus 3 and x plus 2. Oh my goodness. Plus 2 and x minus 3. You know, one of these days I'll get this right. So, alright, finally I have this right. Ugh. So those cancel, and I end up with negative x plus 3 over 2x minus 1. Thankfully I'm done with this example. So now let's have you try an example. Go ahead and write the following fraction into simplest form. So I'll reveal the answer on the count of 3. 1, 2, 3. And so with this example, you'll notice that I factored the top using AC method. I factored the bottom using sort of the simple version of the AC method. And then I wrote out the factors, and then I canceled what I needed and brought the negative to the front, and there's the answer. Going back, though, there is something I forgot to mention. And let's go back through. Here we go. So back when my first example where I did this, it's important to note that when we cancel that, we need to combine the fact that we know x should not be negative 3. Otherwise, this is no longer an equivalent. An equivalent expression. Similarly, going back to here, we have that when I canceled the x minus 4, I should have written that x does not equal 4. And here, I should have that x does not equal 1. Now, why do we do this? Well, we always know when the denominator was 0 at the very start, and the domain is implied when that was the case. However, this is precisely the reason why we need to remark about the x not equaling some number, because when we cancel, we need that domain to be the same for it to be an equivalent algebraic expression. Okay? Namely, in the example I did earlier, we had that our domain, this domain is actually x not equal to 1/2. which is why when we canceled the x minus 4, we had to write in the x does not equal 4 as well. For more practice at working with rational expressions and doing the simplifying of them, be sure to look at page A42 of the textbook and look at problems 2 and 17 through 30. In our next video, we'll use what we learned in this one to handle operations with rational expressions.